Welcome to this special explainer. Let's jump right into this, because today we're stepping straight into the arena for a seriously epic mathematical battle. We are taking on a legendary opponent from the GATE 2014 computer science exam. Now, it's a number system problem that looks incredibly intimidating at first glance. Honestly, it's kind of like a final boss waiting at the end of a really grueling dungeon. But hey, don't worry, we are going to break it down, strategize, and conquer it completely. So grab your mental gear, because this is going to be a really fun one.
And boom, the threat materializes right before our eyes. The question asks us to find the number of possible solutions for the equation 1, 2, 3 base 5 equals x, 8 base y. It's totally understandable if you're feeling a little anxious staring at this setup. I mean, we've got two unknowns here, x and y, and they're completely wrapped up inside different base systems. It literally feels like the equation is shielded by heavy armor. How do we even begin to strike at something like this? Well, every boss has a weakness, and the very first step to defeating this one is to strip away its magical defenses.
Section 1. The magical decimal conversion. Powering up to reveal the mathematical truth.
Watch how quickly this seemingly invincible enemy gets reduced to the basics. Our very first move is to convert both sides of the equation into a language we all understand perfectly, the decimal system, good old base 10. So let's look at step 1, the left side. We have 1, 2, 3 in base 5. To expand this, we just multiply each digit by increasing powers of 5, starting from the right. So that's 1 times 5 squared, plus 2 times 5 to the first power, plus 3 times 5 to the 0 power. Do the quick math there, 25 plus 10 plus 3. That gives us 38. Moving right along to step 2, we attack the right side, x8 in base y. We're going to apply the exact same logic. That's x times y to the first power plus 8 times y to the 0 power, and that simplifies beautifully to just x times y plus 8. And now step 3. This is where the golden truth really emerges. We equate both sides, 38 equals xy plus 8. Just subtract 8 from both sides and we're left with a beautifully simple pure core equation, x times y equals 30. The product of x and y must be 30.
Section 2. Hidden Rules of Base Systems. Discovering the hidden jutsu to avoid deadly traps.
Okay, so we have our target, x times y equals 30. Now, I know what you're thinking. You might be tempted to just list out every single number combination that multiplies to 30 and call it a day, right? Hold up. This is a GATE exam question. The enemy definitely has a second phase. There is a trap here. The absolutely crucial point here is understanding the unbreakable law of number systems. Think of it as our hidden jutsu for this battle. The rule is simply this. The base of a number system must always be strictly greater than any digit used inside that system. Let's think back to our original equation. On the right side, we had the number x8, and its base was y. Because the actual digit 8 is sitting right there inside the number, the base y has to be greater than 8. I mean, it's literally impossible to have an 8 in a base 8 system or a base 7 system. So condition number 1 is locked in. Y must be strictly greater than 8. Furthermore, since x is also a digit in that exact same base y system, x must be strictly less than y. These two constraints are our shield right now. Without them, we are for sure going to fail the level.
Section 3. The Clash of Combinations. Testing our attacks against the magical red barriers.
All right, it is time for the final showdown. We need combinations of x and y that multiply to 30, but they absolutely must survive our base constraints. Y has to be greater than 8, and x has to be less than y. Let's launch our combination attacks. Attack 1. X is 1, y is 30. 1 times 30 is 30. Is y greater than 8? Yes, 30 is definitely greater than 8. Is x less than y? Yes, 1 is less than 30. It passes. That's a victorious green orb for us. Attack 2. X is 2, y is 15. 2 times 15 is 30. Is 15 greater than 8? Yes, it passes. Another green orb. Attack 3. X is 3, y is 10. 3 times 10 is 30. Is 10 greater than 8? Yes, just barely, but hey, it counts. A third green orb secured. Now, prepare for attack 4. X is 5, y is 6. 5 times 6 is exactly 30. But wait a second. Focus on y for a minute. The value of y here is 6. But our hidden rule stated that y absolutely must be greater than 8, because the digit 8 exists inside the original number. Since 6 is definitely not greater than 8, this attack violently crashes and shatters against the barrier. It is an invalid solution. It was a trap perfectly laid out by the examiners, but our hidden jutsu saved us.
Section 4. The Ultimate Victory. Claiming the magical solutions.
Let's move to the final result and see how this all builds to our triumph. We successfully collected exactly 3 green orbs.
The valid pairs are 1 and 30, 2 and 15, and 3 and 10. Because that final pair, 5 and 6, shattered against the base constraint barrier, we are left with the definitive answer. There are exactly 3 possible solutions to this seemingly impossible gate equation. We went from being completely overwhelmed at the start to totally triumphant. By just breaking the problem down to decimal logic and strictly applying the hidden rules of the base system, we defeated the boss flawlessly.
What a fantastic breakdown, right? It really just goes to show how a complex problem is so often just a simple problem hiding behind a mask of confusing rules. So as we wrap up this explainer, I want to leave you with this final thought. In the vast universe of numbers, what other hidden rules are waiting to trap you on your next exam? Keep your eyes peeled, always verify the basic constraints of the system you're working in, and never let the initial armor of a tough question intimidate you. Thank you so much for joining me on this mathematical adventure, and I will catch you in the next explainer.